efficiency. An efficient estimate is one which has the smallest standard error among all unbiased estimators. The best estimator is the one which is the closest to the population parameter being estimated. Okay. Look at this example over here. Right? So that's a dartboard, as you can see. Each dartboard has several examples. The first one has all its shots clustered tightly together, as you can see over here, but none of them hit the center. The second one has a large spread, but around the center, right? The third one is worse than the first two, because you can see everything is spread out over there. Only the last one has a tight cluster around the center, therefore has good efficiency. If an estimator is unbiased, then its variability will determine its reliability. If an estimator is extremely variable, then the estimates it produces may not on average be as close as the population parameter as a biased estimator with small variance. Okay. Alright, this part over here just shows us that once you have the sample, the best way is to have the sample mean and the sample median, and then you're able to make unbiased estimations once you have the sample mean and the median. Right? However, the mean estimate is useful if you're trying to estimate the population sum or some other function of the expected value of distribution. Number 5. What is margin error? Estimation is the process by which simple sample data are used to indicate the value of an unknown quantity in a population. Results of estimation can be expressed as a single value, known as a point estimate, or a range of values referred to as confidence interval. Whenever we use the point estimation, we calculate the margin of error associated with that point. For example, the estimation of the population proportion by means of sample proportion. The margin of error is calculated often as follows. There is the formula. So, in newspapers and television reports on public opinion polls, the margin of error often appears in the small font at the bottom of a table screen. However, reporting the amount of error only is not informative enough by itself. What is missing is the degree of confidence in the find. Okay, so what that means is that when you hear a poll or some kind of research being done, there is a margin of error, and they're supposed to tell us what that margin of error is. So, the more important missing piece of information is the sample size. That is, how many people participated in the survey. Is it 100? Is it 100,000? You know, by now, you know well that the larger the sample size, the more accurate is the finding. Okay, guys, so that'll always be a thing. The more larger the sample size, the more accurate the finding. The reported margin of error is the margin of sampling error. There are many non-sampling errors that can and do affect the accuracy of polls. Here we talk about sampling error. The fact that subgroups might have sampling error larger than the group, one must include the following statement in the report. Other sources of error include, but are not limited to, individuals refusing to participate in the interview and inability to connect with a selected number. Every feasible effort was made to obtain a response and reduce the error, but the reader or viewer should be aware that some error is inherent in all research. So next time you read a public poll or something, just check it out and see, what is the margin of error at the bottom. Alright. Okay, so the margin of error can be reduced by one or a combination of the following strategies. Decreasing the confidence in the estimate, an undesirable strategy since confidence relates to the chance of drawing the wrong conclusion. 2. Reducing the standard deviation, something we cannot do since it is usually a static property of the population. 3. Increasing the sample size. This provides more information for a better decision. Okay.